Hey everyone, so here we'll be solving this find the most comparative subsequence problem, and we're also continuing with our stack playlist. So what it says, you are given an array nums, okay, and you are given k equals to, and you are given a variable k which is right now it is k equals to 2. So what you have to form, let's say you form what? You form all the subsequence of 2 length, all the possible subsequence. Here I have written few, but you let's say form all the subsequence of 2 length, and you have to make sure few things to form a subsequence. uh, the important one is the ordering of elements. Let's say if in subsequence you are using these two elements 3 and 5, in subsequence you are using 3 and 5, so you have to make sure that the order in which 3 and 5 came, it should be preserved. Like 3 was coming first, then 5, so this was right, sorry, this is right, but 5 and 3, it is not true. Okay, this is not correct because the order is changed, because 5 should come after 3, not before 3 here, if you see this. Okay, so what you can do generally in brute force, what you can do, you can make subsequence of k length, like here if you see, by preserving the order, obviously. And then what you have to do, see, you have to find the most comparative. And what do you mean by most comparative? The most comparative means, let's say you see lexicographically, means dictionary order, in dictionary order, which is the smallest. Or even if you see as an integer, 26 is the smallest. Okay, 26 is the smallest. So don't, I mean 26 is the smallest. If you see this 35, 52, 26, 56, 36, and so on, 26 is the smallest integer. So in any ways you can think of, so by considering a dictionary order, which means lexicographically, or integer wise. Okay, so what you can do in brute force, you can try to find all subsequence of k length, all the subsequence of k length. You can either make a string of it, or obviously make a string, and then try to short the string, in the entire string, and get the first one. Okay, if you can consider this 35, 52, 26, if they are your strings, then obviously if you short 20, 26 will be at first, ascending word sorting. So in this would be your brute force. Okay, obviously if you see the time complexity, shorting you will take n log n at like in average, and this is your string itself. So it will also add up to its n time. Okay, because the length, or I mean I'm going to say k. Okay, because this is a string. So the complexity is obviously is the worst that you can even think. Now let's, because we need to optimize this. Okay, because we need to optimize this, and right now I don't have any idea how to do that. So again, let's go back and on this test cases and try to find certain things. Okay, so here I have given this test case, and k equals to 4, which means, let's say I have to fill how many? 4 positions total. And this is normal array, so let's say start from left to right. So you encountered 4. Okay, let's put 4 here, no problem. You encountered 5, no problem, let's put 5 here. Wait, I'll need index, so I'll just write all indexes as well. So, and now see guys, you encountered 2, so 2 should have gone here, 2 should have gone here, all right. But if you see, if you directly see here, look, 2, if you see this 4, 5, 2, and then when the space is remaining, see guys, I'm not trying to say any, I'm not trying to convey any tips and tricks. It's just your perception, it's just your observation that you can get from here directly. So 452 and something like this, or 42 something something, two somethings, well, two digits, which one you consider will be smaller? Which one you consider will be smaller? Obviously this one, right? This would be, because 4500, 4200, so this wouldn't be smaller. So here we are getting some sort of observation like this. See, 2 is lesser than 44, and 2 is lesser than 4 and 5. So even if so what we can say, 2 is lesser than 4 and 5. So, and see guys, you know, in normal mathematics, why 2 here is and 5 here, they are creating this much of impact, because if you see, this is units place, tens place, hundred and thousand. Okay, so these front places, they are of much greater weightage. Okay, so let's leave this right here. This was simple like mathematics shit. So 2, you got 2 here, right? So normally the way we are putting, we are just filling 4 blocks, but what I am saying is let's see that can we, like whatever we are filling here, can we improvise it, can we make it most comparative one, can we make it smallest or in lexicographically order, which means let's see 2. So obviously 2 is lesser than both of this 4 and 5. 2 is lesser than this, 2 is lesser than both of this 4 and 5. So even here if you see, if 2 replaces 5, so you know 4 2. If 2 replaces 4, then what would happen? 2 5. Okay, so is 2500 is smaller or 4500 is smaller? Obviously 2500. So 2 can replace both of them, 40 and 4 and 5. Okay, and if it replaces, we will be getting smaller than whatever we are getting right now. Okay, but the question arises the same, from where, which direction 2 will, like, which element 2 will remove? Will 2 remove 4 or will 2 remove 5? Can 2 remove both of it? Let's see. See guys, if 2 removes 5, which means you'll be getting sequence like this 25. But if you pay attention here, and the condition that you cannot change the ordering of elements, so 5 and 2, 5 should come before 2. Okay, here 5 is coming after 2. So this is for sure. If you want to remove, like if you see, if new element is coming and you see this, the previous elements are lesser, sorry, are greater, previous elements are greater. So this is for sure that a new incoming element, it can have, it have potential only to replace the last element. From left to right traversal, it has potential to replace the last element, not from the starting. Why? You saw this, if you remove 4, you'll get 25. But 25, this is not correct. See, it is smaller, but it is not correct way, because 5 2, 2 will 2 is coming after 5, here 2 is coming before 5. So this is what you're getting as a hint. You want last element. Okay, last input element, that is what you want. So when 2 was coming right here, right now 2 is not in this block, 2 is not in this block. When 2 was coming, it saw that 4 and 5, I can be smaller. If I replace them, the subsequence will be smaller. So let's try to replace this. Now see, 2 replaces 4, 2 replaces 5, 2 replaces 5, 2 replaces 5. And see guys, one more thing you have to make sure that, why, when I say that 2 replaces 5, how would you do that? See, if you consider 2, if 2 replaces 5, let's not put 2 here directly. If 2 replaces 5, so how many positions are remaining? If what I'm saying is, if 2 replaces 5, so there are 3 positions remaining, 1 2 3. Right now don't think that 2 is filled here. What I'm saying, if 2 replaces 5, there are 3 positions to be filled. You have to see that including these two, are there 3 elements? Are there, because see, if you replace 5, you are remaining with 3 positions right here. So you have to fill 3 positions somehow. See, 2 is saying that I can remove 5 to make a smaller subsequence. So that is what you are seeing that, look, here 3 positions are remaining. So that is what you are saying, that with this 2, if you include this 2, is there, like, are there 3 elements here? But here if you see, there are how many elements? Size, if you consider the size of this, so 8, because 7 is the index, or size is 8. 8 minus 2, there are 6 elements. If you count 1 2 3 4 5 6, there are 6 elements. How many we wanted? 3 we wanted. So yeah, 2 can confidently remove 5. So 2 removed 5. But again you see, 4 2 4 2 4 4200 is smaller, or 20, or something like, see, 2 can replace 4. I'm saying 2 can replace, 2 cannot swap the position with 4. Why? Because see, 4 2 is correct ordering, because 4 is coming before 2, but 2 4 is not. 2 4 is not, if you see. So that is why I'm saying it will replace, it will not swap, it will replace. So can 2 replace 4? If you see this, if you replace 4, how many positions are remaining? 4 positions are remaining to be filled. And after 2, like, including 2, are there 4 positions? Yes, there are. So 2 will replace this as well. So now this is your thing. Okay, now let's see 8. It was coming, 8 was coming, so there is no way it can replace someone. Okay, now see 3. Obviously 3 can replace 3. If 3 was coming, 3 can replace 8. 3 can replace 8. Let's replace it. Okay, because if you see, when you remove 8, you are having 3 positions, and here you are having more than 3. In fact, at least 3 you are having. So this 3 can confidently replace 8. But then if you put 3 here, 3 cannot replace 2 because 2 is not a smaller, sorry, 2 is not greater than 3. Then came 5. You will put 5 here, no problem. Then came 1. See, then came 1 here, guys. So 1, if see, 1 should have been here. Primarily 1 should have been here, but no, it won't sit here. Why? Because it can replace 5. So let's replace 5. So, and why I'm saying that it can replace confidently, because if you replace 5, how many elements, how many positions you want to fill? Two positions you are remaining to be filled. And how many are you getting with this 5? 3 positions are remaining. Sorry, 3 elements are there. Oh, sorry, not 3, 2 positions are here. And after, if you remove 5, how many positions you can fill? You can confidently you have to fill 2 positions, and with this one, including this one, and afterwards you are having 2 positions, two elements right here. So 5 will be removed and 1 will be here. So 2, 3, or 1. Now see, guys, could this one have replaced 3? Could this one, because obviously 3 is greater. So if you see in this way, if you remove this 3, let's not put 1, you remove this 3, let's not put 1 right here, you remove 3. How many positions are there right now after 3 is gone? 3 positions, 1, 2, 3. And with this 1, how many elements are there? Only 2 elements. So you have to fill 3 elements, you have to fill 3 positions, but there are only 2 elements. That is why even though one was having potential, this one was having potential to remove this 3, but it won't remove. So right now your configuration is 2, 3, 1 and an empty space. Then came 2. Obviously 2 will be here. Let's say if there was some more element, 5, 6, 7. So when 5 was coming, so already 4 spots are filled. So 5 will not sit anywhere, right? 5 will not sit anywhere. So how will you get that information? See, because you have to tell that 5 you cannot be in any of these spaces, because these spaces are already filled, these spaces are already occupied. So you have to also tell 5 this thing, okay, that 5 you are there's no empty space. So in this block, let's say you wanted to fill 4 elements, you have to just see that is there any space or not. If it is not, then you will directly say 5 you cannot be here. Then come 6, then come 7. Look, obviously they cannot replace this 2, 5, 6, 7, but you have to somehow, because see, you have to somehow tell if there was any empty space. Let's say k was 5. If there was empty space, then 5 would have came here and 5 would sit here. But as whatever spaces we want, they have done. Okay, so now let's see what observations we got. And you see, look, it was simple linear traversal from left to right. We did nothing else. Okay, what we did here, if you try to observe what we did, the simplest thing, if you see this from this 2, so 2 removed 5, then 2 removed 4, 2 removed 5, then 2 removed 4. Okay, so you removed, yeah, which means first thing, when new incoming element, and what it wanted, what 2, look, if 2 can remove, either 2 would directly sit on the place, 2 would directly sit here in the empty space. But if it has potential to remove, then whom it removed? It removed the last element. It removed the last elements. Okay, so if you see from left to right traversal, it removed 5, then 4, which means it removed last elements. So last input element. And who gives you this power of removing last element? Obviously LIFO thing. LIFO means you should go for a stack. Okay, and in that, this is a pop operation. Remove means pop operation. Great. So now let's see, guys, what solution I have, because see, this is a simple left to right traversal. Okay, left to right traversal. There's no hard and something like tricky that I would again explain with using a stack. But let's go and see the solution part, because I hope this thing is done. The intuition part is done. That why are you using a stack? Because when 2 was about to remove 5 and 4, so 2 started removing from 5, then 4. We saw that 2 could not remove 4. 2 could not remove 4, because if 2 removed 4 here, the subsequence will look like this, 2 and 5. But this is not of correct order, because 2 is coming before 5 here, but here 2 should come after 5 in real test case. Great. So now let's see the solution. Now see, guys, here I just wanted to clear this, that here if you see, I'm not using a stack, I'm using vector. Why is it? Because see, the properties that I would be using, that would be of a stack. Last input element, or removing the last input element, all those things I'll be using of stack. But here in C++, the whatever functionalities stack offers, vector will offer the same. Okay, like even more than that, but vector has the properties of a stack as well. Okay, and here in the test return type, here in the return type of this question, you have to return a vector. So if you use initially stack, then you have to convert into to vector, then you have to return that vector. But I know that vector offers a similar functionalities as of a stack. That is why I've used vector directly. Now let's see. As we were doing that left to right traversal on this test case, 452 835, something like that, 83512. So you are doing left to right traversal. So this is the simple loop that will be doing left to right traversal. Now see guys, when let's say your k was 4, your k was 4. So this condition, if you see, I'll come back to this while, because this is the heart of your stack, this condition. But let's focus on this condition. Okay, let's focus on this condition. So what it says, first thing, let's say you wanted to enter 4. Okay, you wanted to enter 4. So there is no one sitting here. So which means the size of, if you call this a and s, so you want to fill 4, but right now as a and s you have not put any element here. So what is the size? Size is 0. So you want 4, but size is 0, then you will directly push 4. Okay, you have to check this, right? Then 5 was coming. This 5 cannot replace 4 because it has not it has no potential to remove 4, because 5 is obviously greater than 4. So what you have to see, is there any empty space? Because see, 5 cannot remove 4. So can it sit here or not? And how will you check that? Can it sit here or not? If is there any empty space? So in your answer vector, is there any empty space, which means what's the size? Size is 1 because you put 4, and 1 is less than 4. You wanted 4, you are having only 1, so put 5. Now comes 2. See guys, 2 has the potential to replace 5. And how will you get that? See, first, inside your answer array and answer vector, you should be having some size. Okay, if the size is 0, then obviously you cannot remove anything. Size is 0, you cannot remove anything. So first, the thing is, you have to check what is there, is the size non-zero or not. If it is, then you'll go back. Sorry, you'll go forward here, and ans dot back, which means the last element. See guys, this is the property of vector that offers you LIFO thing, last element. So last input element 5, is it greater than your new incoming, which is 2? Yes, it is. Then let's see the third thing, guys, that I told you, that if you're removing 5, how many elements you have to, right now you have to put here 3 elements. See here ans dot size -1, which means you are removing 5. Let's say, how many elements are remaining right now in this vector? Only one element. Only this 4, only one element is remaining. So how many elements you want to fill? K -1, 3 elements you still have to fill. And then you have to see that in your initial nums, whatever you are getting in that the test case, whatever you are getting, so nums dot size minus I. So from this element till last element, are you getting at least 3 element or not? See, when 2 was coming, when there was test case right here, so see, when there was test case right here, so if you remove 5 in a way that I would put 2 here, then you have to see that if you remove 5, then including this 2 and onwards, are there 3 elements or not? At least 3 elements. Are there 3 elements or not? Then only you can remove 5. Okay, because you have to fill 3 elements, right? So this is what you are doing here. You're checking that you want how many elements at least. Now after 5 is removed, you want 3 elements at least. And if you are getting 3 elements, then you will remove 5. Okay, once you removed 5, you went for 4. You saw that, yeah, 4 is also there, and 4 is also greater than 2, greater than me. So can I remove 4 as well? Yep, you can, because ans dot size is 1, not it's not 0. Then you saw the last element, which is 4, and it is also greater than 2. And again you saw, if you remove 4, how many elements you want now 4 elements. And including this 2 in the remaining part, how many elements you are getting? You are having more than 2. Okay, how will you get the information? Nums dot size minus I. If you see simply nums dot size minus I, you can write it on paper and see, and it will work. Okay, so you'll again pop back. Then this while loop will terminate because size became 0. You also remove 4. Then you will see here, you will go back like on this point. Now your size is 0 and you wanted 4, so obviously you'll put 2 here. Okay, so in this way guys, and then finally you'll return ans. See, I know this would be a lengthier video, but again, do let me know in comments you are getting the hints of an intuition how to use a stack or not.